Okay, everybody, I'm back and I'm going to do part two. Part one of the pre-recorded screencast for August 29th was about 32 minutes. So I'm going to go about 35 to 40 minutes, and we're going to look some more at where we are. And of course, there's the announcement. As I mentioned, I'll be sending everybody an email out and this about this. And again, this is because as I was putting my schedule together, I forgot all about convocation. And it just is, I never know if I'm going to have enough time to run back, take my, get my robes off, all that business. So I just thought I'll do pre-recorded screencasts for this class and for another class I have at 2 o'clock on Wednesday. And then I'm going to be there. So if folks have questions, they can come by, and I'll be sending an email out and so forth as I promised. I want to go back to the modules, okay? And back in part one, I showed everybody how to get the solver set up in Excel, and I had provided you some resources, okay, in terms of using Excel, and I've got some other files. I want to make sure that you understand I've got student data files. Now you're also going to see, usually you'll see on the workshops, you're going to see that I tell you, okay, this is, here's the file to upload for Par Inc. Here's the file to upload for Nolan Plastics. And again, I walk you through it, and it's important for you to understand that I do these workshops for a reason. I don't really believe you can kind of understand what management science is all about until you put it into practice. And business is a performance-based thing. You either do it or you can't. And I also work through problems that you're going to run into in some industry at some point or the other. Plus, this gets you prepared for some projects and hands-on types of things that you'll be doing when we come to the end of the course. So I don't assign these just for busy work. I assign them to show you. And one of the things you're going to find out is that the optimization is a remarkable approach, because it says I operate within certain constraints in order to get an outcome. Now, where we really begin to see, and we'll see this where we begin to see some real value, is when we move down to the end of the course and we start to use things like a simulation. And when we do that, we're not only creating a mathematical model, we're also adding the ability to say, given the constraints, if we make these changes in the constraints, here's what we get. Now, this is very intuitive, and I'm going to open, you recall back in part one of this, I went in and I added the solver. Now, I'm going to go over here to the Nolan key, all right, and I'm going to click on data. All right, and you'll see that there is the data analysis tool pack and the solver tool pack. I'm going to click on solver. And again, what this does is it provides us a nice menu where we put in the objective function, that is the answer. We indicate one of the three. We're trying to maximize something, minimize it, or we have a target value. Then we begin, so we're talking there about the nature of the problem we're dealing with. In Par Inc., we were using break-even analysis to look at selling price, production, fixed costs, how, if these change, or if we have certain, if we build into these constraints certain values, what does it look like? Now, then we have the variable cells, and those are the things that, those are the variables that are impacting some operation that we're involved with. Then we have constraints, and then we have to come to grips with the question of, do these data look linear? Do they look nonlinear, or what? And of course, as you saw in part one, where we looked through the textbook, we saw the use of the graphical solution, where we identify a feasible region on a Cartesian plane, i.e. a really, really fancy way of saying we use algebra to make a linear algebra to make a chart. And we identify a feasible region. The feasible region, and I'm gonna close this for just a second and diminish this, and I'll go back over to the textbook. Here's that optimal solution. This is the best we can do in terms of profitability based on the number of deluxe bags we make plus the number of standard bags. This is the high point. And then we see the dots that show us the optimal solution. And then we see at what I would say a core or optimal region. Okay. And then these are also feasible, but not optimal. The solver tool does that for us, and it puts it in a chart form and in a form that we can understand a little easier. Now, if you have a strong desire to do linear algebra, be my guest. But I want to point out something to you very important. Everything we do in management science uses a template or a theoretical construct. We use a known approach. Here we're using linear algebra. We use tools that are out there that we can apply to management problems. I can't emphasize that to you enough, which is why when you take a look at these, for example, and we'll go back here for just a moment. I'm going to open that back up for us. Here we're looking at, we're dealing with the total cost curve. And total costs are variable costs plus fixed costs. We're looking at contribution margin, which is the revenue per unit minus the variable costs per unit, which it means how much have we got left to pay our fixed costs. And again, you'll remember if you took 1123 with me, we talked about that company, Badger Jams. And remember we did the break-even chart and the analysis. And so not too much different here. And in this case, we're going to use the what-if analysis, and we use the goal seek. Now, if the data, for example, here, the fixed cost or if this is junk, we're going to get, as I've said it before, garbage in, garbage out. Now, what the authors don't spend much time doing, and they really couldn't, is speak with us about how I got these numbers. And that's something that that I don't care if it's accounting, finance, or management science, or marketing, anytime we use a quantitative model, we need to make absolutely sure that we've got good data. Now, in this case, this might be data from industry standards. This might be data from historical costs. Who knows? But what we always want to be mindful of is this: data tortured sufficiently will confess to anything. And that's true. It's kind of an offshoot of, figures lie and liars figure. I go back to the presidential election in 2016, and all of the models, the best people were the folks at 538, and you can find them online. They were predicting that Secretary Clinton had about a 7% lead on Trump, and that she'd win. Now, on a national basis, she did. But hidden inside the data models were gremlins. A little gremlin called Ohio, Wisconsin. One of the fascinating stories that's out there now, and of course, a lot of people are writing, what happened? And the Democratic Party is going, what happened? Because those models had worked so well when former President Obama ran. But Secretary Clinton's not former President Obama. So models that they thought would work again just didn't. And it was about 200,000 people who decided the fate of 330 million of us. One of the people who said, okay, what happened? There are two stories out of all of that I think are interesting. One is the Democratic Party chairman in Wisconsin begged the Clinton campaign to come to Wisconsin. Wisconsin had voted regularly with the Democrats. The rural areas of Wisconsin would vote Republican. The the urban areas in Wisconsin would vote Democratic. They'd have more votes, and so the Democrats would win. But something had happened. They never came. And she may have cost herself the election. Those folks in Ohio, one of the analysts said if you'd gotten off the interstate and driven through some of those areas that had traditionally been blue-collar Democrat strongholds, and you saw house after house after house after house after house with Make America Great signs, and people running all over the place wearing Make America hats, you might have said, well, the national model's working, but here in this local model, here in this locality, it's not. There are always gremlins in the data, and we have to be looking for them. This is just part of decision making, okay? This course is as much about an approach to decision making as it is about crunching numbers or using models, because it says, and I can't emphasize this enough, the outcomes, possible outcomes, our best job is to try to find, given how constraints work, or if we manipulate those constraints, let's say I get labor costs down, for example, I'm going to get a different result. But the results we get from making our decisions are more along a continuum as opposed to being black or white. They tend to run along a continuum into an area of really good things or an area of really bad stuff, or, you know, kind of this or that, kind of in the middle. So we can never, ever, ever forget that. And the beauty of this approach is it lets us look at possible futures. Now, I've taught strategic planning and policy here at OBU and at other places. I've worked with strategy and in the real world, and I can tell you, I don't care how well you have a plan devised, the first time you implement it in reality, it falls apart. There's a saying in the military, the best plans come to an end when the first shots are fired. And people who are military historians will tell you that great battles typically are decided by 2 or 3 sub-battles within that battle. Well, that being said, again, you know, I walked you through in the part 1, we walked through how do I set up Solver and what does Solver do for me. Okay, so we've got this model that we're working with. And here are the extreme points on the feasible region for par Inc. Now, this is a fairly happy equation because we have multiple good outcomes. We have this feasible region. And you can see we've got, you know, outcome 1, 2, 3, 4, 5. And we evaluate the extreme points. Now, the authors walk us through the computer simulation, and this is something that we'll talk about quite a bit. But I wanted to use part 2 to speak with you some about, well, what is it that we get? Now, this figure 214 that's over on page 53, this is the solution for the par Inc. problem using a web file. Now, there's the authors give you an option. You can either use some software that they have at the companion website, or you could use Excel. I choose to use Excel simply because I think it's designed to teach you how to use it. And I don't know for sure, but let's look at this for a minute. Here's the optimal objective value is $7,668 in profit. Here are the variables. How many standard bags are we going to make? How many deluxe bags are we going to make? The value of the dollars we'll get, the values, the number of them we're going to make, then any reduced costs. And then we see the constraints, 1, 2, 3, 4. Remember we had those 4 constraints like cutting and sewing, inspection, etc. And then we look for any slack or surplus. And then we find a thing called the dual value. All right. And the dual value is very synonymous to marginal value. For every unit that I work with, constraint 3, I add 6.94 basically to the solution. And dual value is it's marginal. It's the marginal outcomes I will achieve per unit. Then we see, of course, the objective coefficient, the variables, any allowable increases. Again, do we want, well, here's how many more we could make. Here's how many we could not make. And the same thing for the deluxe bags. And then there are the constraints. And this is valuable information right here. the allowable increase and the allowable decrease. This begins to tell us our constraints. It's not a perfect analogy, but probably the best way to think about this is to think about standard deviations. Okay? That's how I think of it. I get an optimal value, but I've got some standard deviations. I could increase or decrease, and here's what I'll get. And they walk us through some of that interpretation. The authors talk some about the slack variables, and we have slack time and slack in terms of the sewing constraints. So we've got some resources we may not be using there. All right. Now this thing of the dual value, I'm going to do a quick search here. And here we are. You see the value. And here on page 104, we get a really clear explanation of what that's all about. Dual value talks about the improvement we'll get if we add to or subtract from one of these constraints. It's a change in the objective, and the authors tell us this, but it's important for you to understand this. It's a change in the objective function, value per unit increase in a constraint on the right-handed side. And they give us an example. And I believe I have some verbiage in there, and they show us an example here using what the dual value is all about. And it's important that you get it. It's also sometimes known as the shadow price. But I know you'll want to get that into your brain. And here it tells the manager, as it says in 104, how much more one unit will give you. What's the marginal revenue? In other words, if I produce for each additional unit I produce, what do I get? Well, I want to go back here for a moment to the module, pardon me, to these resources. And I want to take you real quickly over to take a look at Solver in Excel. And this takes you over to Excel Easy. Now let me say this. I've worked with spreadsheets longer than most of you have been alive. So I understand spreadsheets and how they work. And I can tell you for a fact that Easy Excel, or Excel Easy, is the best tutorial source on the net. Now YouTube has some great stuff. And I think often, I often will say, hey, go over to YouTube and take a look. And you'll see someone who's posted something very, very well. Well, here's the solver, and they talk about the solver, and they show us some transportation problems, shortened paths, capital investment. They give us some examples of how to do the add-on. And they show us formulating a model. And then here comes the part that's really important, the idea of trial and error. This moves us to the point where, you remember with goal-seek, I can change the variables. The mathematical model, the beauty of it is it's like a plate, okay? What type of meal do I want to put on it? if I'm going to serve beef, if I'm going to serve beef, is it going to be steak? Is it going to be hamburger? What are we going to do? What type of salad am I going to make? It's all based on that notion. So this is a great resource, and I really encourage you to take a look at it. And so that's why I have that for you. And I also have a how to make a transcript of a YouTube video. And so you can get transcripts from the videos, so you can read it as well. Now, this covers the GRG nonlinear. I'll talk about it for just a second. Okay. And what types of problems GRG nonlinear deals with. And you'll want to take at that. Interestingly, see, the GRG nonlinear says we believe the data don't fit that nice little graph we had that's linear. These data are nonlinear, and so that means we can get two types of solutions, local and global. And the authors do a good job of explaining that the solver finds a locally optimal solution. In other words, in that particular situation, it works, but this may not be something that you can transport to other situations. And so I think you'll want to take a look at that. And again, I've got those resources there for you, and I hope you'll take a look at them. And then here's Excel Solver Evolutionary. Let's take a look at it. And this talks about good versus optimal solutions. And what the evolutionary is, that approach in solver. The mathematics are way beyond where we want to go. But the solver tool will say, hey, I'm just going to keep churning through this until I get a good solution, or I get the best solution I can get given the number of trials I intend to run. And they give you some ideas on handling it and working with it. I have a resource there for you. One of those I like to point out to you, Fighting ISIS with an Algorithm, trying to identify people, bad folks. And so you can see there's some resources, and I'd like you to take a look at those. And here's the Nolan Plastics key. We did Nolan Plastics is due the 31st, and you'll just download the key to your desk and then upload it here. Now, when I do a screencast for Monday, we're not going to have class, but I'll go ahead and do a screencast anyway. It's there for you to look at on demand. We'll walk a little bit deeper into M&D chemicals. We'll talk about this concept of the left-hand side and the right-hand side, and how we are starting to work with these variables, play with them, and see what types of results we get. And then we'll start to look at the output that we get, say, from Excel versus this software that the authors have at their companion website. And you have M&D that will be due. Par Inc. will be due on the 7th. And then you have 2 quizzes that will be due as well. So we'll dig into them. I'll dig into them some on Monday. We have no class, it's Labor Day, but I will probably do a pre-recorded screencast. Again, these two screencasts, this one and part one, are in lieu of having a live screencast Wednesday the 29th. Wednesday 29th, I forgot, is commencement, and it's just a real stretch for me to get over there, get out of my robes, get set up, etc. So I said I'm gonna do away with that. I don't like to rush in terms of my preparedness, so I'm just gonna have these two here for you. You'll get your 75 minutes of instruction. I'm saying basically the same stuff I would have said anyway, and you can read it. Look at the transcript. You can look at the video, the screencast, and I'll post it over here so there will be two pre-recorded sessions, part one and part two. And then I'll do something in lieu of Labor Day that you can look at on demand. Okay, folks, I think I'm going to call this a wrap. And I do appreciate your time. I appreciate your forbearance. And I will be sending out an email that explains what's happening. I'll write up an announcement, and I'll probably just write up an email and send it to everybody and post something too. Okay, folks, thank you so much. God bless you. I'll be there at Convocation tomorrow, which is the 29th. And then after Convocation, I'm going to be at my office. I might go to lunch and then come back, but Wednesday afternoon, I will be around, okay? Probably till 3:30 or 4 o'clock, something like that. So if you have questions, you could stop. So that's what's going on. And instead of a virtual, I guess I'll probably, since I have a computer over there, I'll probably go ahead and do a virtual office hours, but I'll be there physically. Okay? Thank you much. God bless you. And I'll see you at Convocation tomorrow.